This is a problem work through for problem 60 from lesson 2.6 Gravitational Acceleration and Free Fall. A ball is dropped from a window 20 meters above the ground. How long does it take the ball to reach the ground? The information that we can take from the question itself is that the ball is dropped from a window and that it's 20 meters above the ground. So those two pieces of information tell us that since this is a gravity free fall, that the initial velocity will be 0 meters per second because the ball is dropped out the window. It also tells us that x, the distance, the displacement from the window to the ground, is 20 meters. Now, in part A, the ask for this question, the unknown, it says how long does it take the ball to reach the ground? So that means that time is our unknown quantity. Once again, since this is a gravity free fall, our acceleration is the acceleration due to gravity, which is the known value 10 meters per second squared. Now the formula that relates v sub I, x, t, and acceleration, g in this case, will be x equals 1/2 acceleration times squared, so we'll use g times squared, plus initial velocity multiplied by t. Now in this problem, we do need to isolate t because that is our unknown, but we have t in two places. So this proves to be a challenge. Isolating t in this case would be very difficult, but what we know is that since velocity, our initial velocity is 0, this term, 0 multiplied by t, it ends up disappearing. So we can just ignore it and drop it off. So that means all we need to do is isolate t in this portion of the formula. So let me rewrite that. We have x equals g t squared over 2. Because remember, 1/2 times anything is the same as that divided by 2. Now if we want to isolate t, let me highlight that there. If we want to isolate t, we can multiply by 2 over g. That cancels out the 2 on this side, and that cancels out the g as well. But whatever we do to one side, we do to the other, so 2 over g, and we get 2x over g equals t squared. Now here, to get t by itself, we have to get rid of that exponent, so we take the square root of the right side, the square root of the left, and we get t equals the square root of 2x over g. Now, we rewrite that up here at the top. T equals the square root 2x over g, and now we plug in our values from our laundry list. So 2 times x of 20 meters over gravity, which is 10 meters per second squared. Remember, this is all under the square root. So we end up with 2 times 20, which is 40, divided by 10, which gives us the square root of 4, which is 2. Now, you'll notice I left off the units here because I wanted to focus on the numbers. What I have in this fraction is meters, which is over 1, and that's divided by meters per second squared. Now, let me just draw a line here to keep this separate. What this actually looks like is meters over 1, and we can, since we're dividing fractions, we can change that sign to multiply, and we flip this second term. So we use the reciprocal. So it's s squared over m. So that shows that the meters cancels out, and we're left with seconds. So inside the radical, we have seconds squared. The square root of 4 was 2. The square root of s squared is s, which makes sense because the variable we're solving for is time. So it takes 2 seconds for the ball to reach the ground when dropped out of a 20-meter window. Underline that. Put it in a box to make sure that it identifies as the answer. Now, for part B, let's move this up just slightly so we can still see the laundry list, but we can look at part B. Part B asks, what is the final velocity? So VF is our unknown for this, and we can use any of the three remaining formulas for acceleration. Realistically, the simplest one in this case is probably final velocity equals initial velocity plus gravity multiplied by time. And the reason that becomes the simplest is because the initial velocity is 0 meters per second. Gravity is 10 meters per second, and time that we just found is 2. So when we substitute our numbers in, this becomes a 0, so I don't even need to write the units because it's just going to disappear. And gravity is 10 meters per second squared, and time is 2 seconds. So 10 times 2 is 20. Seconds will cancel with one of the seconds here, and we're left with meters over seconds, which is the units for velocity. So 20 meters per second is our final velocity. 2 seconds was the time it takes to hit the ground.